Hi. Yeah, thanks for being here and listening to my talk. So yes, I'm a PhD student at OVHcloud and Tima Laboratory in France. And this talk is about using Chisel in our environment production for Agile networking hardware at OVHcloud. So I will start with a bit of context, then we'll see motivation about why do we want to use Chisel in production, and then we will see what we have done to de-risk Chisel, and then to upgrade our design flow to include Chisel in our design flow. So first, the context. You may not all know the OVHcloud company, so it's not really known, but quite a huge cloud provider. And among all the figures here on the slides, the one that I'm quite interested in is the huge bandwidth we have at the entrance of an OVHcloud network. And when you have a huge bandwidth at the entrance, it means that you are vulnerable to a lot of kinds of attacks. And one of these attacks can be distributed denial of services, when you have a lot of traffic coming to kill one server, or at least to saturate it. And so my team at OVHcloud is working on anti-DDoS, and we have developed a custom solution which consists in deviating the traffic into a scrubbing center. And in this scrubbing center, we have our own custom solution that we call VAC, for vacuum cleaner. And in this solution, we have both CPUs and a bunch of FPGA to mitigate the attacks. So since we are using FPGA, we have some issues with being agile, because the fact is that attackers are agile. Each time you set up a new mitigation techniques, they came up with new strategies. And since our solution is made of both hardware and software algorithm, we have to cope with the idea that software is quite agile, but with lower performance than hardware. And so how to close the gap between this hardware development and software development. So in the past, we've tried HLS, high-level synthesis, but in the end, we reduced performance with our FPGA without gaining much in agility. So the question now is, can we just improve agility with HCL, such as Chisel, without losing performances? So this slide just presents the difference between hardware description languages and hardware construction languages, but I guess you are quite aware of what we can do with Chisel. For us, the big idea is to be able to do a lot of parameterization, functional parameterization, type parameterization, and also to switch between this poor event-driven description, where you have to use tool-dependent syntaxes and features towards a nice object-oriented presentation of the hardware. So now, when we started to look at Chisel, we had to assess that it was ready for us. And what I've done as a first step in my PhD was to look at one of our biggest module, which is actually a simple counter store, just to count the number of packets or bytes in a flow from one given IP address to another, or such kind of flow. And it took me a few months of dev. At the same time, I was discovering Chisel and Scala. And I achieved to pass existing and new validation tests. And the most important, get the equivalent resource usage for the same throughput after FPGA synthesis. So I published an article this year about that. And another issue we had is that the Chisel was originally intended for ASIC design, most of it. And so it was supporting at the beginning only one kind of reset, which was the synchronous reset pattern, when you can only reset your board on posage clock. Then the asynchronous reset was added by Jack, where you can trigger your reset either on the clock or on the reset. And the idea for FPGA is that as you are on a kind of virtualized platform, you have already some reset mechanisms that are embedded within the FPGA, which is the FPGA internal startup reset. And so in Verilog, we used to use this reset in order to remove all the reset tree from our design, and so get better plus and root results. So I added this after a long-running PR on FireRTL, and we are really happy to be able to use this reset technique in our designs. So then the question was how to integrate Chisel in our existing design flow, with the biggest issue being to embed one given Chisel module inside an existing Verilog hierarchy. And especially, Chisel is able to embed black box. So it's quite easy to have your top level in Chisel and to use existing IPs from System Verilog or and so on. But we didn't want to change everything from the beginning. So given a simple hierarchy with this M1 and M2 modules, and then you have this A module, which is once parameterized with a X, and the second time parameterized with a Y. The question is, how do you propagate parameters that are given by the top and propagated by parameters, respectively? So when you design this same module with Chisel, it is able to get parameters, which will give you two distinct Verilog files. And this Verilog file, AX or AY, are not able to replace the module A in context because they don't take parameters anymore. So what we decided to do is to do kind of hacky things with what we called a param wrapper generator, which generates, given the module in Chisel and a set of parameters, it generates a big switch case, only partial, given the parameters given. And this resulting module, which is a bit of gibberish, but is able to replace one for one with the existing Verilog modules. And so we can, without changing anything in our existing Verilog hierarchy, using Chisel for one given modules. And this was really successful because we were able to change one hashing module, which was used in many places with very different parameters in our design, and it was done in a very hacky way in Verilog by instantiating some memories that was going to be simplified by the tools, and we gained a lot in simulation time and synthesis times, and it's enable for us, it enables a very smooth transition between our huge existing code base in Verilog and the use of small Chisel IPs. And then the question I asked myself was, since I'm quite able to do a manual translation between a Chisel module, between a system Verilog module, assuming it is a synthesizable system Verilog module, I can easily write myself the equivalent Chisel module with the basic features of Chisel. I would call that low-level Chisel, only using hardware primitives. So this is feasible to translate the system Verilog to Scala, to Chisel. But if you have large cost bases, it becomes a really long and tedious work where you can do a lot of errors. So the question was, are we able to automate this process? And the answer is yes. So it's a bit of a challenge because you have to retrieve a clock and reset with the same issue as synthesizer and simulators do have with event-driven descriptions. And the other things is you have to choose the best types. Because in System Verilog you always use bits that don't have any types, because for example, to do logic or arithmetic, you have the same vector of bytes, and you don't care about it is if it is a new int or if it is a vector of ball, for example. So the idea is to choose the best type to avoid the most of the casts depending on the module. And the idea behind that was to be able to bring a new agile upgrading flow with first this automated translation from system Verilog to Chisel, and then the interesting parts when you switch to Chisel, meaning that you can now use all the interesting parts, functional parameterization, object-oriented description, and you can do that manually based on something that is already working, and this is really interesting to do. And for this, I published this open sourcely, but it has not been really updated since the publication. And I've wrote a small paper on this as well. And so the conclusion now about our use of Chisel in our production environment. So our current evaluation of Chisel is that the translation does not bring a lot of benefits, but it is quite easy actually to convert once you master Scala and the Chisel syntax. It is quite easy to translate one for one an existing system Verilog module. It becomes much more interesting and much more rewarding when you are actually using the great feature of Chisel, when you are actually using parameterization, functional parameterization, and you deal with types and so on. And the integration of Chisel was a bit painful, but once you are all set up, it works quite smoothly, and you benefit from all the advantages of the integration of Scala test and so on. So the continuous integration with Chisel modules is quite easy to set up if you compare to continuous integration with system Verilog. And finally, the worst thing we have to say about Chisel is the use of the test Chisel tester. We put a lot of effort in it in order to make it for our own taste and usage in the team. But in the end, we put a lot of effort, and we think it's not quite usable right now, for us. And so our future works will consist in developing all the new feature with Chisel because it's working really well. And for the test, we were trying to switch to CocoTB, because the main advantage for us is that you completely switch the language in which you write the test, so you cannot use the same logic. And since we didn't achieve to reuse all the existing data structure coming from the Chisel in the test, at least you use a complete different language. And in addition, CocoTB can also replace our existing test bench in Verilog, so we can get something really uniform between Chisel and system Verilog. So we dream at fully replacing all the system Verilog. It will ask a lot of efforts. And finally, in the case of my PhD, I'm currently working in introducing a pipeline, so oriented network pipeline abstraction, to go further with Chisel and to introduce almost a DSL on top of Chisel, just some new libraries. And so I'm currently working on this and trying to get this published. So thank you for watching. I'm really pleased to have presented, and do not hesitate if you have any question.